Hello, and in this video we will walk through how to create branded AMI images based on the CentOS Cloud Image Release. This is for use in Openstack. The first thing we need to do is download the CentOS Cloud image. On the CentOS website, they provide regularly made cloud images that you can download and use for yourself. In our case, we were just going to download the raw image rather than downloading and converting. The first thing we want to do is create a working directory. Next thing, we obviously need to unzip the downloaded image. Now we have our uncompressed raw image from the CentOS Cloud. If we look at the file, we will see that it's actually just a disk image, complete with a partition table. This has the consequence of creating a disk that cannot be extended when the system is built in Openstack. While there are ways around it, such as using LVM or just extending the file system, they're not always prone to work. What I recommend is just to extract just the partition itself and use an AMI image to bundle your kernel, your RAM disk, and your disk image. We begin by using kpartx. If you don't have it, you should install that package. We are just going to load that disk image, and you will see that it creates a loopback device. Dev loop 0. That actually also creates a mapper. So what we can do is we can call into the mapper in our dev directory, and you can see for that loop, we actually are now creating that loopback device, sorry. We can now read the partition and map it to a logical device. So in this step, we're actually going to read that partition itself and output it to a raw file. At this point, we have a raw dump of the XFS partition. At this point, we no longer need the raw disk image. Now we need to mount that raw partition to a directory. I created a temporary directory in temp, and I mounted it there. At this point, you can use chroot into that directory using your favorite shell, and now you can customize your image as necessary. In my case, I'm going to install EPEL. As you can see, we have a problem in that we cannot actually access external files. This is because inside of our image we do not have a name server set. So you can see I'm actually adding the name server to the resolve.conf file. As you can see now, we can install our repos. Another package I'm fond of installing is Puppet. We use Puppet extensively in our environment. So I've created 2 repos. Now I think I'm going to install a package from that repo. Now this is great. I have Puppet installed on my machine by default whenever I deploy this image. But maybe there's some other tools I don't want. Maybe I don't want the Crony package. I'd rather use NTP. And I have some other packages I like to install on my system. Maybe you do too. How many of you hate SC Linux? That's the first thing that I disable. Now, these are all default settings I've created in my image. When I'm finished, I can just exit out of my shell. At this point, the image is ready to go. But we still need to create an AMI image. In order to do this, we need to create a RAM disk image as well as a kernel image. With these 2 separate images, now we can create a machine image, and this will allow us to bundle everything into one AMI package. So we're going to begin by copying the kernel out of the mounted image. We're going to do the same with the RAM disk. When that's done, we can unmount our partition. Now, I mentioned earlier, we need to copy the kernel into Glance by creating an AKI image, otherwise known as an Amazon kernel image. We need to repeat the same for the RAM disk by creating an ARI image, otherwise known as an Amazon RAM disk image. now we have the ARI image and the AKI image and uploaded to Glance. Now we can create a bundled AMI image based on the kernel that we just uploaded. The RAM disk that we just uploaded. And we can create the AMI image. Obviously, we cannot pass the name as a RAM disk ID. I mishighlighted. With the image uploaded, we're going to create one more image. We all like web servers, right? We exit out of our shell. We unmount our partition image. And we create a new CentOS image. And now, when you look at your image repository, you'll see the images you had just created. You can now use these images to launch a new instance in Openstack.